Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to write the expression for the equilibrium constants when you have solids and liquids as part of your reaction equation. And again, these are called heterogeneous reactions. Heterogeneous because you've got different kinds of states involved in your reactions, and in this case some of those states are going to involve some solids and liquids. And remember that when you're expressing your equilibrium constant, you're not going to include solids or liquids because solids and liquids do not change their concentration as the reaction is proceeding to equilibrium. Okay, so we're not going to include them in the expression. Alright, so here in the first example we have calcium carbonate solid, and that's in equilibrium with calcium oxide and carbon dioxide gas. So you have calcium carbonate going to calcium oxide to carbon dioxide gas, and we see that this is a solid and the calcium oxide is a solid as well. The only thing we have that is not a solid is the gaseous carbon dioxide. So, so this is the only thing that's going to be in our expression. Let me make sure I got this correct. So make sure it's balanced, and it looks like it's balanced. So all of these are one coefficients of one. So the Kc is going to be, again, the expression is the concentrations, and notice we have C there, so we want Kc, not Kp. Okay, so even though this is a gas, we want this in terms of the concentration of that gas. So we're going to have concentration of CO2 written here. So CO2 in square brackets to the power of 1. Now, normally we would multiply it by the concentration of the other product and then divide it by the concentration of your reactant or reactants. But since this product and this reactant are solids, we're not going to include them because, again, the concentration of a solid doesn't change during the course of the reaction. So this is the expression of Kc for this reaction. Okay, what about number 2? So number 2, we have 4 HCl gas plus oxygen gas, 1 oxygen gas, plus that's going to yield 2 H2O liquid and 2 chlorine gas. So we've got gases for our HCl, oxygen, and our chlorine, but we've got liquid for water. So it's a liquid, so we're not going to include this in our expression. So again, it's asking for Kc, we want Kc, so even though these are in gases, we're going to express this in terms of concentration. Okay, so again, products over reactants. So the only product we're going to write down is the Cl2. So we're going to have Cl2 in square brackets. We take the 2 coefficient becomes power of 2. So we're going to square that. And that's the only product we're going to write down. So liquid water, we're not going to write that down. Pure liquids are not in the expression. So now what about our reactants? So the reactants are going to go on the bottom. We have HCl, so that's going to be 1 reactant, HCl, concentration of HCl raised to the 4 power 4. And then we have oxygen, so we're going to multiply that by concentration of oxygen. And there's a 1 coefficient there, so there's going to be a 1 there. And that's it. So this would be the Kc expression for this reaction. So I hope this was helpful. Remember that whenever you're writing down the Kc or Kp, Pure solids, pure liquids are excluded from that expression. You're only gonna, anything that's a gas or aqueous is gonna be in the expression. I hope this was helpful. If you like this video, please like, share, subscribe, hit the notification bell. Thanks for joining me, and I'll see you next time.